Okay, now we're going to continue our discussion here of integrals by applying another set of formulas to help us integrate. And in this case, we see we've got a sine times a cosine that we're integrating. Well, this should bring to mind the product to sum formulas. And for the sine cosine case, I've already given you the formula here off to the side. So let's go ahead and take a look at that one. All right. If I have sine of 8x times the cosine of 5x, I can rewrite this as the integral. I'm going to write the 1/2 on the outside, but I will rewrite it as the integral then of sine of a plus b, which if this is a and this is b, I'm going to write it as the sine of 8 plus 5x, which is 13x. All right, plus, okay, sine of a minus b, so 8 minus 5 is 3x, and then I'm going to write it as a dx, okay? Cannot forget the differential. So everything has a 1/2 on the outside, so I'm going to split these up, split up these integrals. First, I'm going to write it as half of sine of 13x dx plus half of the integral of sine of 3x dx. And then I'm going to do some very basic u substitution, and you're not even going to see it. So derivative of the inside of the first one is derivative of 13x is 13. So I'm going to write a 13 right here. And by consequence on the outside, I'm going to need a 1/13 that I'm going to multiply by. And the same thing's going to happen over here, except here I need a 3. And so by consequence, a 1/3 that I'm going to multiply by there. All right. And that should take care of my u substitution and make for a very simple set of integrals here. All right, we get -1 out of 26. Okay, let me clean that up a little bit. -1 out of 26. And then it's going to be the integral of sine, which is going to be a cosine. All right, and it's actually negative. So there's my negative. Now I know why I had a negative there in the first place. All right, a negative cosine of 13x. All right, and then the integral again of another sine is going to be another negative, so -1 out of 6 by doing that simple multiplication. Cosine of 3x in this case plus c. So really nice simple integrals if you use those product to sum formulas. And let's go ahead and take a look at another example. We're going to call this one number 8. All right, and this one is very similar. We're going to use another product to sum formula. So let's see what it looks like. So we've got sine of 7t times the sine of 3t. So dt. This is the case of a product to sum, but this is the case where you have a sine. So let's see what a sine looks like. So sine a times the sine b. All right, is going to be 1/2 again, but in this case you have the cosine of a minus b, all right, minus the cosine of a plus b. So again, if you're struggling with this right here, these are just some identities from pre-cal. You're going to want to look up the product to sum, all right, formulas. Product to sum formulas. That's what you need. All right. So that's why you studied those in pre-cal. All right. They help you out again in calculus. All right. So let's take a look then. Let's continue. I'm going to rewrite this integral as 1/2. And I learned my lesson from the last time. So I'm going to write it first as the cosine a minus b. So it's cosine of 7 minus 3, which is 4t dt minus, I'm going to put another half. I'm already breaking it up just to simplify it a little bit. And then it's going to be the cosine of a plus b, 7 plus 3, which is 10t dt. All right. Now, again, pretty simple. U substitution. I need a 4 here. By consequence, I'm going to write a 1/4 on the outside that I'm going to multiply by. And over here, I need a 10, and I'm going to multiply by a 1/10 again on the outside. All right. So let's see what this looks like. This looks like a 1 out of 8. All right. Integral of cosine is a sine positive, sine of 4t. All right. And then 1 over 20, so minus 1 over 20. Again, the integral of cosine again being sine, but in this case sine of 10t plus c, your constant of integration. All right, really nothing to it. All right, again, making use of those identities from pre-cal, the product to sum formulas. So as always, I hope this video was helpful, and remember, like and subscribe.